Electromechanical devices are growing in use in certain applications, replacing sometimes the hydraulics previously used. So to start our conversation, Eric, what is driving the shift from hydraulics to electromechanical technologies?
There's several factors. It's a transition that's been happening just from the other experts I've worked with for probably 15 to 20 years now. It started as a concept back then, but now it's been a reality probably the last 10-ish years. Um, but the main shift is just the cleaner energy. So with hydraulics, you have to have oil, obviously,
Hmm.
and you have to have. There's more that comes with that. You have oil filters. You have to keep it pressurized. Oil leaks out of those lines. It's definitely an older technology, but doesn't mean that it's bad. It's just electromechanical can serve a purpose in a certain force range, and all you have to feed it is electricity.
Hmm.
You don't have to worry about all of those other things like you would with hydraulics. The cost might be more upfront, but in the long run, cost of ownership, it is worth it.
And so when might it make the most sense to use an electromechanical device in place of a hydraulic one?
There's always going to be a need for hydraulics. When you're talking about tens of tons and hundreds of tons of force, you would need a massive roller screw, in
Mhm.
many, many feet in diameter to even use that kind of when you get up to that kind of force. But there is a force range where electromechanical and hydraulic overlap, and I think that's where it makes the most sense. Um, when you're not having to worry about, pressing metal with, hundreds of tons of force or oil drilling or that those kind of applications. Those are always going to be hydraulics until something else comes along. But
Mhm.
um, but for factory automation type settings, electromechanical is, in my opinion, granted, I'm probably be biased because that's my business, but
Yeah.
electromechanical just makes more sense.
Hmm. Right. You were saying there's a kind of a force range where sort of either or could you explain like what is that
Mhm.
force range or
Well, with Rexroth products, I forget the maximum range that our PLSAs, planetary roller screws, go to. I want to say it's in the around 10 tons, but that and anything below we would be able to handle with either a ball screw or a roller screw,
Mhm.
PLSA screw. Yeah.
Mhm. Okay. All right. Well, I know the company recently introduced a new size to its line of PLSA planetary screw assemblies. What maybe prompted the introduction of that new size and how do these components aid with that transition or just implementation of electromechanical devices?
So the 48 by 20 PLSA we just released the new size and lead. It's a longer lead. Most of the PLSAs have a 5 millimeter lead or 10 millimeter lead, meaning that they can go 5 millimeters or 10 millimeters in one rotation of the screw. With the 20 millimeter lead, it doubles a 10 millimeter lead when in one rotation. So pretty much you can go faster um, in less turns. It also uh, helps with keeping the friction and heat down. That's one of the challenges with electromechanical versus hydraulic. Hydraulic, you can move as quickly, not as quickly as you want, but a lot more faster than you could with electromechanical because you don't have metal on metal contact with friction and heat being created. So with the new size and the new longer leads, you can move faster and have less friction and heat build up, so it can compete more with the hydraulic cylinders.
Well, you were touching on some of the benefits that this component provides. Are there additional benefits or kind of, you know, are there are there going to need to be maybe some um, additional subassembly like this technology or component developments to help to aid with that continued transition to electromechanical devices?
With hydraulics, I would imagine there's a lot that goes into setting up a hydraulic apparatus. Like I said, you have the oil, you have to have it pressurized. There's oil filters. You have to replace those oil filters at certain intervals because they get dirty. And then the piping or the tubing on the oil lines, I know those have to get replaced as well. And like I said, it leaks. There's just a lot that goes into it.
Mm.
Um, but it's a more well-known technology because it's been around longer. With electromechanical, you usually have a motor, drive, and control that control the screw or cylinder, and you can do pretty much an infinite amount of positions. Where hydraulics, that's usually point A to point B, and you're just going back and forth. So the electromechanical solution would be a lot more flexible. So for customers that do various size parts or whatever on the same line, um, an electromechanical solution would be the better option, the easier option.
So do you maybe foresee any other technological changes or needs, as applications shift to the use of electromechanical devices?
I don't see the PLSA advancing technologically too much. Um, it's pretty basic in how it works, but there's definitely a mindset shift that needs to occur. So you have people that have been working with hydraulics for 30 years in their respective industry, and that's what they know and that's what they're comfortable with. And that's fine. As people move out of the workforce, younger people come in and they see and understand the benefits of electromechanical. I think that shift will accelerate. It's something that when we released our PLSA, 11, 12 years ago, they thought it would happen a lot more quickly than it
Mhm.
has,
Yeah.
with that change in mentality. But I think it's inevitable that it will happen. Companies realize that the cost of ownership of the PLSA, is a lot more business. It makes more business sense
Mhm.
um, than the hydraulic option.
I've heard that from a few other people too, that kind of, yes, there's those the operational costs, and then also with the transition of generations into various industries and that knowledge of hydraulics and everything kind of leaving a bit that's kind of aiding with this shift. So
Yeah,
but great, yeah.
I would compare
Um,
it to like internal combustion cars versus
mm,
electric cars. There's going to be customers that, no, I only want an internal combustion engine. Electric vehicles, they're not the answer. Okay, that's fine. But then we've had hybrid cars where it kind of combines the best of both worlds. I would kind of compare that type of mentality to the hydraulic versus electromechanical.
mm, mhm. Yeah, no, that's a good comparison. Yeah, great. All right. I think those are all the questions I had for now. I really appreciate you taking the time to speak with me today and provide your thoughts on this shift from hydraulic to electromechanical.